Okay, problem 4. The integration of x minus 1 over this. Okay. So the idea is to change this to a sum of two fractions, because your bottom is x squared plus 3x plus 2, which is x plus 2 times x plus 1. Right? So we can rewrite it as a over x plus 2 plus some b over x plus 1. Okay, so we can solve this ab. How do you solve this ab? So on the left side you have x minus 1, x plus 2, x plus 1. Right. On the right side you have a x plus 2, right, x plus 1. So it's a x plus 1 times plus b x plus 2. Okay, so now you can check the coefficient of x. Here is 1, right? Here the coefficient of x is a plus b. So your first equation, because left equals right, so 1 equals a plus b. Okay, your second equation here, the constant part is negative 1. Right, the constant is negative 1. The left, the constant is a. The constant is 2b. Alright, so negative 1 equals a plus 2b. And you quickly solve this. Right, your b is negative 2, your a is 3. Okay, so now we can start our integration. So it should be 3 over x plus 2 minus 2 over x plus 1. Right, here you don't even have to use the substitution method. This part, you read it, it's lowering absolute value of x plus 2 derivative, right, minus 2. This part, the integration, it should be lowering absolute value of x plus 1, and then you plus c. Okay. So part 2, again, we deal with the fraction first. It's x plus 4 over x plus 2 times x plus 3. Right? So again, it's a plus b, which is a x plus 3 plus b x plus 2 x plus 2 times x plus 3. So read the coefficient of x, it's 1 plus a plus b. Sorry, 1 equals a plus b. Right. What about the coefficient of the what about the constant? The left is 4, the right is 3a times plus 2b, right? 4 equals 3a plus 2b. And you solve it. So a is 2, b is negative 1. Okay. So now you can start your integration. It is the integration of 2x plus 2 over plus negative 1 x plus 3. Okay, then this part is 2 lowering absolute value of x plus 2 minus lowering absolute value of x plus 3 plus c. Okay. Part C is a little bit more complicated because simply you just have more terms to put in your equations, right? So here you can see x minus 3, so we have some a over x minus 3. And we have x plus 2 square, so we have b over x plus 2 and c over x plus 2 square. So we have 3 terms. Okay. So it's something like this. So it's like this, and we have to solve it, right? We have to solve it. So we should get 3 equations about x squared, about x, about 1, right? About x squared, you can read the left, it's 1, right? You can read the right, it should be a plus b, right? Because here you don't have any x squared term for c, right? Yep. Then what about x? The left, there's no x. On the right, here you have 4x, 4ax, right? Here you have how many x? You have minus bx. And here you have cx. Okay. And the constant, the left doesn't have any constant. The right, here it's 4a. Here it's going to be negative 6b. Here it's negative 3c. Okay. So for example, these two, you use this times 3 plus last. To use this equation times 3 plus the last equation, you get 0 equals 16a minus 9b. Right, then c cancel out. So your a is 9 over 16b, which you sub back here, right? So your a is 9 over 25, your b is 16 over 25. And your c is, then you sub back here. Okay, it's negative 4 over 5. So now we can start our integration. The integration of this is just the integration of a over x minus 3 plus b over x plus 2 and plus c over x plus 2 square. Okay, and this integration is very easy. It's 9 over 25 lowering absolute value of x minus 3 plus 16 over 25 lowering absolute value of x plus 2. In this part, it's right, it's minus 4 over 5 times negative 1 over x plus 2, right, plus c. So this is your answer. You can simplify this a little bit. Okay. It looks complicated, but the method is quite standard. You just have to follow it, do it, you get the answer. Okay, there's nothing to think about, it's just do it. Okay, part D. Okay, so we use substitution method once. Okay. So we use substitution method once, it becomes u minus 1 to the power of 3 over u to the power of 3 du, which is, you can expand the top, u cubed minus 3u squared plus 3u minus 1 u cubed. Okay, so it's integration of 1 minus 3 1 over u plus 3 1 over u squared minus 1 over u cubed du, right? So the integration is u minus 3 log absolute value of u, okay, minus 3 1 over u, okay, plus 1 over u squared half, right, plus c. Okay, then you sub x back. It should be x plus 1, right, minus 3 log x plus 1 minus 3 over x plus 1 plus half x plus 1 square plus c. Okay. Let's do part T. 1 over x plus x squared plus 16. Okay, notice that tangent inverse x derivative is 1 over x squared plus 1. So it's kind of similar, but it's slightly different because here you have 16. So what we should do, what do? We can divide by 16 on both sides, right? So it's 1 over 16, 1 over x over 4 squared plus 1. So we divide by 16 on both sides, numerator and denominator. Then we can do one-time substitution. U is x over 4, right? Du over dx is 1 over 4. So dx is 4 du. And we sub in, it's going to be 1 over 16 times the integration of 1 over u squared plus 1, right, 4 du. So it's just 1 over 4 integration of this, okay, which is tangent inverse u, right, plus c, which is tangent inverse x over 4 plus c. Okay, or you can use that formula, right? Here we use a substitution, or if you see this type of integration over and over again, you can use the formula, the integration of 1 over x squared plus a squared. It should be 1 over a tangent inverse x over a plus c. Okay. Alright, this is part E. Part F. Okay, first, is it reducible? We check this, right? X squared plus 2x plus 5. So it's discriminant like b squared minus 4ac is obviously smaller than 0, right? So that's why this thing is irreducible. So if it's irreducible, we should find something else to try to solve it, right? It should be x plus 1 squared plus 4 dx. Right, and don't forget about the formula we just introduced. It's 1 over x squared plus a squared integration. It's 1 over a tangent inverse x over a. Right, if I'm right. Yep. Plus c. So here I just want this to be my u. Right. So I can do one step substitution. So here's u squared plus 4 du. Okay, now I can apply the formula. It's 1 over 2 tangent inverse u over 2 plus c. A final step. Just sub x plus 1 back. Okay. Part G. X squared plus 4x plus 13. So again, this stuff is irreducible, right? It's irreducible. The bottom is irreducible because your b squared minus 4ac is smaller than 0. So what should I do? Alright, if top is a constant, it's much easier. We can do as what we do in part F. But top is x. I don't want this x. Right? I don't want this x. Alright. So let's see what we can do. So if we use the substitution method, let's see. If we use the substitution method, so du over dx is going to be 2x plus 4. So I hope my numerator is kind of 2x plus 4. But now it's not 2x plus 4. It's just x. So I can pair it, right? So I can make it, I can plus something to make it a multiply of 2x plus 4, right? So I can use x plus 2 and then minus 2 to make it a multiply of 2x plus 4. So for the first part of this integration, okay, let me just put the 2 outside. So for the first part of the integration, I can use substitution method, right? It should be 1 over u, right? But your dx, so you change it a bit, so x plus 2, it should be x plus 2 times dx, it should be half du. Alright, so here, this part, it should be half du. And minus 2, so now this part you can apply the same trick. It's x plus 2 square plus 3 square dx. Right. So this part is half ln absolute value of u. And this part, you can apply the formula again. Right. You can apply this formula again. Okay, now A is 3. And tangent inverse, x is x plus 2 over 3. Okay, plus c. So it's half ln absolute value of x squared plus 4x plus 13 minus 2 over 3 tangent inverse x plus 2 over 3. Okay, plus c. And because this part is always greater than 0, right? So you can remove the absolute value. You can remove the modulus and leave it like this. Okay.